Hello everyone, in this video I will go over how to determine whether a function is even or odd. F is an even function if f of x equals negative f of x. Now recall that f of x or f of negative x is going to be the y value when the input is x or negative x. So these are the y values. And the input for the left side is in positive x. The input for the right side is a negative x. So notice that we have opposite x result in the same y. So notice this looks similar to having symmetry about the y-axis, opposite x, same y value. So when we have a function that is even, the graph of the function is also symmetric about the y-axis. Odd function, we have the function f is an odd function if f of negative x equals negative f of x. So again, this is the y value. But notice that there, on the right side, we have the opposite, the negative y value, instead of a positive y value. So for the same as for the opposite x values, we have opposite y value. So notice that is very similar to having symmetry about the origin. We have xy on the graph. There's going to be the opposite coordinates, negative x, negative y on the graph as well. So for an odd function, the graph of the odd function is also symmetric about the origin. Now let's look at an example. Determine whether each function is even, odd, or neither. Also discuss about the symmetry in the graph. Part A, in order to determine whether this function is odd, even, or neither, sometimes it could be both odd and even, we have to check. So what we're going to do is we're going to replace the input with the opposite x, so f of negative x, and see if it's going to come out to be the same as the original f of x or the opposite of f of x, or neither. Negative x raised to the third, replacing the x with the negative x, 2 times negative x. And then simplify this one. Negative raised to the odd power is going to be negative. And then negative times a negative is going to be a positive. So notice that these terms are opposite. So the outputs are opposite. Opposite input x, opposite output y. So when this happens, the graph is going to be symmetric about the origin. And in terms of whether it's odd or even, opposite x, opposite y is going to be an odd function. All right, now let's take a look at part B, g of x equals x squared plus 1. So what we're going to do now is replace the input with the opposite. So that's going to be g of negative x, and then simplify to see if this would give us the same output as the original g of x or opposite outputs, or neither. So we can replace the x with the negative x, and then simplify. Negative x squared raised to the even power is going to become a positive. So notice how it looks exactly the same as the original g of x. The output is the same. So opposite input x result in the same output. So when this happened, opposite x, same output y, opposite x, same output y. This is an even function. And with even functions, the graph is symmetric about the y-axis.